Okay, well, thank you very much for inviting me. Thank you, Sean. Very nice to be here, and I feel that I'm in distinguished company of people who know an awful lot more about power systems than I do, which is good for me, but we'll see whether it's good for you. So I'm an energy economist, and I sort of apologise straight away for being an economist in a sea of engineers, though there are some very distinguished economists here too. What I'm going to talk about is essentially trying to introduce some smarter economics into the smart grid. Now, one of the problems that we have in doing that is actually the economics is already pretty smart around some electricity markets, and my colleague Thomas Grieve is currently on a trip in another part of the US where he's visiting ISO New England, FERC and PJM, and talking to what they're already doing in terms of auctions for electricity and associated services. What we're doing very specifically is trying to extend some auction ideas as far as they could theoretically go, while still, of course, maintaining the advantages of auctions. This is part of a government-funded project in the UK, which is a consortium with a large number of other universities, mostly engineers. In fact, we're the only economists, but we don't hold that against them. And the idea is that these engineers have is that what they envisage is a sort of self-star network, which is self-healing, self-configuring, basically run. I think what the original idea was it was just going to run itself remotely, and there wasn't even going to be a system operator. Of course, I've had long discussions about whether that was ever a possibility from a policy point of view. But we've taken their idea and actually learnt some sort of key things from them. First of all, we're interested in these aspects of the smart grid, and there's sort of the idea that everything will be more active both on the demand side and on the supply side. The idea that there'll be a very large number of players on both the demand side and the supply side. And a sort of central idea, which is I think the one that is worth pushing, that there will be unlimited computer power by 2050. That there's no constraints in our ability to process information. And I think, of course, there'll still be behavioral constraints that we were talking about in terms of our ability to react to information if we're relying on human responses. But in theory, the processing power should not be a constraint. Now, of course, that doesn't mean that there isn't a problem in that some of the algorithms may not actually solve efficiently, but it does mean that the speed of getting to the solution, we assume, is not the issue. I'm not sure anything really hangs on. Is it about are we expecting energy prices to rise? I think the more important thing is that we need processes for arriving at prices within the energy system which are politically defensible. And of course...
Can I ask a question about your assumption? Does that mean you can solve NP-hard problems?
I'm not making any assumptions about that, okay? I'm simply saying that if it's about solving a large number of simultaneous problems very quickly, we can do that. Okay, so I think that one of the reasons why we don't have auctions bigger than they are at the moment is because it just takes too long to solve the problem. So it's not necessarily that there's a sort of solution algorithm problem. Okay, so that's the sort of background. What we're going to focus on is the design of auctions to handle these large numbers of buyers and sellers, potentially. And the idea that, I mean, one of the central problems is, of course, that although you can have nodal pricing, and this is something I think we're still conceptually getting our heads around, one of the fundamental problems of nodal pricing is the lack of competition at each node. That yes, you can have every connection, every piece of DG, every customer defined as a node, but that doesn't really help with competition. So that clearly is not very practical to do that. What we need are unconstrained zonal areas, which may be very absolutely small, but are potentially competitive and which do compete with one another. So that's in a sense what we're thinking about. And of course what we're thinking about is extending the idea of competition down to a very small scale level, where you could have, very small numbers of GG, very small numbers of active customers, essentially competing to resolve a price between them. Okay. A bit about auctions. Economists do like auctions when they work. I mean, the problem with auctions is they don't always work. And the other problem with auctions is that the players in the auctions may work out how to game the auction, in which case the auction needs to be redesigned. We're sort of abstracting from that. Of course, if you have very large numbers of relatively not particularly sophisticated players, where it may not be worth trying to game the auction. And we've also got some ideas about how you could, in a sense, regulate gaming. Two key aspects of auctions which are worth trying to emphasize are you want auctions to be efficient in the sense that they arrive at the right outcome in terms of who is generating and who is being supplied. And then you want some sort of optimality in the auction, which of course in a power market auction is that the lowest price is being charged. Okay, so because those are not necessarily the same things. So you don't want out of order running of plants if you can help it, out of merit order. That would be inefficient, but you also want the price to be as low as possible, which is what optimality is about. A central theme in auctions is you want people to tell the truth about what their true willingness to accept in terms of if they're a generator, or their true willingness to pay if they're a piece of demand. And you want people to truthfully reveal that, which of course would help you to arrive at an efficient solution, which would also be optimal. But of course people may have incentives not to do that and not to tell the truth. Another important idea in auctions is that if you're trying to encourage truth-telling, it should be second price. People should not be paid as bid, because if you're paid as bid, then you have an incentive to shave your bid. Whereas what should happen, of course, is that you have an incentive to bid truthfully, because the bid that you put in on your own piece of generation does not affect the price that you're likely to get for it. Okay, and that is a central idea in auctions, and very few auctions can achieve this consistently. One of the problems is how do you deal with multiple units? So I think I was talking to John, who was here yesterday, about the fact that some of the ways that we think about auctions are only applicable to a single unit context, i.e. there is one Picasso for sale. How do we arrive at efficient price for that? What auction process arrives at that? The problem that, of course, we have in electricity markets is there are multiple units for sale, megawatt hours, if you like, and people can supply different amounts of them. So that's what's called a multi-unit auction. You need to worry about the fact that, of course, if people are bidding to supply multiple units, they can win some, but by manipulating their bids on other units, they can drive up the equilibrium price. There's an example of that there. So you need processes which handle that. A very interesting idea in auction theory, which I think is something that should be of interest to power systems economics, is the idea of the proxy agent, which is something that I think most of us understand from eBay. The idea that you can, tell eBay what your maximum price is that you're willing to pay for something, and then eBay's software puts your bid in against other people's bids, and you definitely won't pay more than that, but you could pay less, and because there's a proxy agent bidding on your behalf. Now, of course, this is a particularly important idea for DG, because we don't imagine that individual turbines are going to have to put in bids every day. You could simply submit your willingness to accept payments. You could do it even once every 6 months, and the proxy agent simply bids you in every period according to your pre-announced schedule. And of course, proxy agents can aggregate bids from different small players and be bidding, putting multiple bids in on behalf of many different players. And they can also be a mechanism for ensuring that for monitoring anti-competitive behavior, because of course the proxy agent can be programmed not to allow people who may be pivotal in particular zones to bid more than a certain amount. Okay. So what our claim is that some of the auctions that we've got at the moment aren't particularly efficient. They don't handle this multi-unit problem particularly well, and we haven't got enough use of proxy agents on behalf of small DG. So these are sort of things we might want to introduce into the auction. At the moment, when we have zones within the electricity system, or within an electricity system, they are not flexible. Okay, so they are fixed. PJM West or ISO New England has different zones, and they're not particularly flexible. Whereas actually, what you would want is that you'd want to observe what the market clearing prices are in one zone. And then you'd want to say, well, could I reallocate some capacity from one zone to another zone in order to reduce total cost? And it is possible to design auctions which might do that. So the zones themselves reconfigure. Of course, that's particularly important where the zones may be very small. They're micro zones, where we would be worried about competition within very small zones, and how to handle that. Okay, so this is what we're going to try and come up with auction design that is small scale and which delivers efficiency and optimality, and makes some use of auction concepts in order to deliver lower consumer prices and improve welfare. So we're going to define some of what we mean by flexible zones. You do, as a supplier, and of course when we talk about suppliers, they could be generators or they could be demand response. So they could be negative bidders. They can go it alone and put their own bids in, but actually they're going to be offered the chance to use a proxy agent, as in eBay. And there may be quality of service variations. So of course one of the auction theory does extend to the idea not only that there might be differences between how much people are prepared to offer and at what price, but there might be differences in the quality of the offering that they're giving. So they're actually offering multiple types of goods. So here what we have in mind is, of course, if you were a wind generator, you might be able to offer some with high probability guaranteed generation. You might be able to offer some more generation where you're not so sure about when you can offer it, but you might be able to offer it at some point during the day. And then there might be, third quality. Of course, we can put in all, more qualities than this, but in this, simple setup, we're going to just have 3 qualities. In fact, I'm just going to show you a simulation or an example with 2 qualities. Okay, so the first thing we're going to look at is just to emphasize what the zoning might be doing and how rezoning could help. And of course, remember, this is all being done by a computer. Okay, so in a sense, people have put in their bid schedule, and actually what we're imagining this could look like is actually what you might do is if you've got a solar panel on your roof or a wind turbine in your back garden, what you would actually do is you just put in the characteristics of the wind turbine or the solar panel, what make it was, what size it was, its grid location, its angle, and the proxy agent would work out what optimal bidding looked like on the basis of weather. Okay, so it could be all you have to do is give some generic purchase quality data, and the proxy agent does everything in terms of determining what an optimal bidding strategy might look like for you. Of course, this is the benefits of unlimited computing power. So here are 2 zones with different amounts of stuff in them. Okay, so we've got some small-scale suppliers who may or may not be aggregated. We've got some wind. We've got some negative demand, this sort of demand response. We've got demand that we need to satisfy, which could be of different qualities because we've got some consumer who are willing to defer their consumption. And initially, we have got some initial zoning, because one of the fundamental points about auction theory is you do need a feasible starting point, or else it's not clear that you can end up at a feasible ending point. You've got to have something that you can improve on. Okay, so so these could be very small. I mean, we've only got very small amounts in here. We're talking about 20 megawatt hours is being satisfied. We've got some bids that are submitted by these generation units, and the gas plant says that, well, I'm prepared to supply up to 3 megawatt hours at the highest price. The wind, there are different renewable generators who are offering lower prices, and we're not going to look at the qualities initially. We've got another auction that does that in a minute. And there is a reserve price, so we're not going to pay, just in case we're really worried, we're not going to pay more than a certain amount. Of course, it's usual in auctions to set reserve prices to make sure you don't get very nasty surprises in your auctions. One of the things to emphasize is this is a multi-unit auction, so people are, I'm prepared to supply you with up to 3 at 120, but of course I would supply you with 1 at 120 as well. And one of the characteristics of multi-unit auctions is you want to exploit the inherent competition between individual units, rather than simply not take any account of the fact that there's divisibility here. The way multi-unit auctions work is essentially you have to break them up into smaller auctions in order to ensure competition. Of course, this is all done within the computer program. So in this case, we've broken it up into 10 smaller auctions which are for 2 megawatt hours each, and where you could only win 1 megawatt hour. Each individual generator can only win 1 megawatt hour in each of those individual auctions. This is what needs to happen in a competitive, to ensure competition in the market. So, here's one of those auctions, one of those individual 10 individual auctions within this particular, within the first zone. And not surprisingly, in this particular auction, the lowest cost bidders win, and of course they win at the price which just excludes the next highest price bidder. If you solve all of this using these multi-unit auction, what you end up with, at least I hope that this is what you end up with, Thomas assures me that it is what you end up with, you end up with 10, to get your 10 units, the first 5 individual auctions clear selling 2 in each, so you've got your 10 that you wanted, and the market clearing prices in those individual auctions are these. Now you can see that the nature of the auction is that you have managed to get the price down on some of the units, and the most efficient units are running. So this is what's happening within this zone, under this multi-unit auction. The second auction, the second, so that was the first zone. So of course now what we're emphasizing is the flexibility point. If you solve it for the second zone, actually there is more cheaper capacity available in that zone. So actually the auction prices in that zone clear at lower prices. So now we've got a situation where one zone has cleared at some higher prices, and the second zone is cleared at lower prices, and maybe there's a potential for reallocation here, because if there's more available capacity here and there isn't any line constraint, then clearly we might be able to knock out some of the high cost generation in zone 1 with some extra generation in zone 2. And indeed that's what we show is possible, that we could rezone and in a sense rerun the auction with the existing bids in order to get lower costs. And indeed that's what might happen here, that there's another 4 units available from these 2 guys at 119 rather than taking the last 4 units from these 2 guys at 165. So rezoning would actually save money within the same auction process. So that's that. And so the thing to emphasize here is we are making use of auction concepts. We think the auction is efficient and can't be, it's a second price auction, so people have incentive to bid truthfully, and by rezoning we've delivered lower prices for consumers. Okay, so there was no quality in there. So now we're going to try and make use of a package clock auction in this micro zone setup. So package clock auction, of course, famously used for telecoms bandwidth, where people were bidding for different bits of the radio spectrum. And of course, individual companies wanted to combine different bits of bandwidth and were prepared to pay premiums for particularly preferred bits of bandwidth. Now, the interesting thing about a package clock auction is that in order to make the auction efficient and optimal, what you have to do is define everything to be the same initially, and then have a subsequent round of the auction where you allow people to bid on particular packages. So the idea is that the initial auction is just for sections of bandwidth of a particular length, but then there's a subsequent round of the auction where you can bid for particular frequencies within the available bandwidth. But the package clock auction is designed to maximize competition in the first stage in order to get in this case, the revenue up for the communications authority in order to maintain competition at the first stage, and then of course bring in some capacity to allow people to express preferences for particular bits of the spectrum in the second stage. Okay, so we've sort of got that idea in here for electricity as well. So there's what's called the principal stage, where in a sense everything is defined to be the same to begin with in terms of different bits of spectrum of a particular volume are all the same, and then we've got what's called the assignment stage, where people can bid for particular frequencies that they're interested in. Okay, so here's where gold and silver come in. And we need to introduce some quality differences here that people might, which relate to the assignment stage. So you're going to face penalties if you can only deliver to one zone. So you haven't got flexibility, you haven't got available distribution capacity that you've paid for, or that you can get access to. So the number of lots that are offered for sale are, we want 10 gold, 10 silver, but the particular, some of them can only be delivered to zone 1, and if you can only deliver to zone 1, you have to pay a penalty if you can't actually get your power across to the second zone or can't handle rezoning. So we want to promote some price discovery. So here's what some of the bids might look like with similar zones to what we had to begin with. So the price in the package clock auction, of course, the prices start off in each round and begin to drop, and then people sort of say how much they're willing to take at those, or to offer the market at those prices. So in round 1, if the prices are 165 for gold, Wind 1 is prepared to offer 5 lots, 5 megawatt hours of power. As the price begins to drop, of course, Wind 1 says, well, I'm only prepared to do 4 at that price for gold at these prices, okay, for the 2 types of power, okay. So so this is a conventional auction where people are all saying, this is how much I'm prepared to supply at the prices that are clearing through the auction. Okay, then, so within the principal stage, you've got rules about whether you can go back in the auction. So there are price caps. So you got up to round 3, and you were prepared to. This is how much you were prepared to pay, or prepared to be paid to supply 3 gold. And there are caps on, okay, if I had to offer 4 gold, I have to go back up to the point at which I dropped out of 4 gold. Okay, so I can't, so in other words, all your previous bids are still in the auction if needed. Okay, if the market needs 4, you can go back to what your best bid for 4 was. But you can't go back. You can't go back and bid more. Say you must be paid more for 4. Of course, you can come back in again and say, well, actually, I'm prepared to pay to accept less for 4 than I originally said. So there's some capping going on. So here's an example of what might happen in terms of who bids what and for what. So this is what the the principal stage and supplementary stage revealed that when one was prepared to supply 4 at this price, he would do 3 for this price, and he would do 2 for this price, where of course the unit price is actually less. Okay, but I'm not prepared to supply 3 at this lower price. Okay, these generators are prepared to pay to supply combinations of gold and silver at these minimum prices that they're willing to accept. So of course the auction then auction process has to work out what's given that these are all the bids that have been revealed in the initial stages of the auction, what's the least cost way of delivering 10 gold and 10 silver? And the answer is, well, you know, these 3 bidders win, because this would be the least cost way of supplying. This is what they bid, and this is what they get, because it's a second price auction. So, you know, this guy, he bid 360 for 3 gold, but there's somebody else who bid 362. So of course, because it's a second price auction, he gets 362. So these are the prices that they actually get based on second price rule, what the next highest bid was. So demand has been satisfied at least cost through this package mechanism. Now we have to take account of the fact that some people actually, you know, I can't deliver necessarily. So there is this prospect for an additional round where people reveal their additional constraints. And given that I face these additional constraints, I'm actually prepared to accept less for my par. And of course, people are bidding into the auction knowing that if they face this constraint, they'll have to accept less. So here, this guy says, well, I really do want these restricted lots which only work in zone 1, so I don't have the capacity to get over to zone 2. So I'll actually bid to accept 2 less if you let me have this restriction on these restricted lots. This guy will accept 1 less. So in the supplementary round, this guy, SS1A, this particular supplier, has bid the least to get these restricted lots, which are of extra value to him or her. So he wins them. And because it's second price auction, of course he pays 1. He gets 1 less, because that's what the other guy was prepared to accept. So there's some ability. So what we've now got is ability to offer different combinations. With the package auction means we can offer different combinations of gold and silver, and the package clock mechanism will solve for that. What's the least cost combination? And if there are further then restrictions on line capacity, we can incorporate that into the supplementary rounds. Okay. And then we can show exactly what the payments would be as a result of this. Because this guy has, only wants to supply in zone 1, he has to pay a penalty, because that was the rule if you accepted that restriction. Okay. And I'll leave that. So what I think we're trying to get towards is the idea that we can extend auction theory down to the distribution system, and that we could have these self-organizing zones which had their own market clearing prices, and where there was competition at the margin between the prices in each zone, and where we made use of the proxy agent idea, so that in theory very small generators and loads could participate in the auction. And of course we are assuming that there's unlimited computing power available to do this. The other thing that we've got in here, which is quite interesting, is the idea that maybe in the long run we don't need capacity markets. So one of the things that we're discussing about this is that, of course, if you why we could just have energy, in the long, capacity markets are a sort of short-run phenomenon caused by all the sudden arrival of lots of low marginal cost generation. Of course, not altogether clear why in the long run you need capacity markets. And we could just get back to an energy-only bid. But because, of course, entry in these, if entry is all small scale, people wouldn't be building their wind turbine or putting in their solar panel unless they were recovering their average costs. So, of course, that would limit the bids that people would be putting in. Okay, so that's why you're getting, non-zero bidding for renewable generation going on here. But we need to think about it in terms of what we would do if there was capacity and energy bidding by individual small generators. Okay, so we think the English auction, which was the first one where it had the rezoning, is efficient, but it's not reflecting the packages of different qualities, and we think the package clock auction can handle the different qualities of generation and potentially the valuation of line constraints. I think that's it.
Questions?
Sure.
So, yes, it almost sounds like you're getting something that wanting somebody to get to for a long time, but I'm not sure. So today, that's part of what you're saying, right? The problem today is that auctions don't discriminate between different suppliers. So you've got one generator that always works, and they supply power, and you've got another generator that breaks down every day, and you treat them the same. Usually in this long history, the one is bronze and one is gold, you treat them as both gold. And
yeah.
Besides that, what you're talking about, but it sounds like it could be, maybe, basically you could learn whether the quality of the different services maybe put into the system. On the other hand, I'm not sure how a supplier actually knows how to define themselves.
Okay.
They don't know the truth.
Yeah. Okay, so I think this is where I think we're on to something. Okay, I think I agree with you on the first point. Okay, that there are different. We can handle different qualities, and we should handle it. And auction theory can handle it. Okay. On the second point, I think this proxy agent idea is really powerful. Because I think, yes, of course, as an individual piece of DG, I've got no idea. The owner of the DG has no idea what to bid. Okay, because it's too complicated. It relies on weather, it relies on characteristics of the equipment. But of course, this is where the proxy agent comes in. I think that essentially what you would imagine is when you might. I don't know, where Home Depot, you go into Home Depot, you buy your solar panel, and at the same time as you buy your solar panel, they give you a proxy agent that you're signing up with. And the proxy agent knows that this Home Depot panel has these characteristics, and the only thing they need to know is your grid location. Okay, and then they can use satellite imagery to work out what angle you've got this thing on your roof at, and they will then solve for your optimal bids, and you can be sure they'll always bid you in optimally according to your design characteristics. Okay, so I think this is where the idea of unlimited computing power and unlimited access to information is really powerful. And we need sort of what we're playing with here is the idea of what would the economics look like if you lifted those constraints. Yes.
So I like this proxy idea because from a control perspective, you want to get people out of the loop.
Yeah.
There was one of the talks yesterday talking about human in the loop, and that's a disaster. But the proxy is now just it's just a feedback control mechanism. Well, it's a block within that feedback process. Certain signals come in, the proxy makes a decision, certain signals go out. Totally repeatable, presumably.
Yes. But of course, it's also you can trust it if you're the the owner of the DG, and also potentially it would be easy to regulate. So you'd say, well, suppliers above a certain size, who are pivotal within particular. So the problem is pivotal suppliers within these little zones. Clearly by bidding strategically, they might be able to manipulate the price. But of course, the proxy agent in theory could handle that. According to some, absolutely clear rules. Okay. The thing I think I've asked Thomas to try and find out is that, PJM is great in theory with locational marginal pricing, but one of the problems of it is there's a lot of funny business going on in terms of how they handle these local generators with market power. And I'm not absolutely clear that that's done on a completely consistent basis. And there may be a lot of ad hoc regulation of their market power going on. Whereas actually what you'd want to do is completely systematize it, which is what the proxy agent idea could do.
Yeah, one thing that wasn't quite clear to me, apologies if I missed something, this was there, is how you decide on the zones. Okay.
Well, that's again, a key idea in auction theory is you've got to have feasible starting points. Okay, so because essentially you're improving on the feasible starting point. So of course the initial zoning does come from line constraints. So of course there will be natural normally unconstrained areas within the distribution system, and those would form the natural initial zones. So of course you've got to start from somewhere if you're solving this, and that's where you would start from. So the question is, can you improve on that? I think the lovely thing about this is, can you improve on that initial zoning? So there's an obvious way to break up the distribution system. This then will allow you to reconfigure it if it's in consumers' interest to do that. Yeah.
And how would you? Because there's definitely going to be a balance of with dispatching these. There's going to be a balance of least cost versus quality. How do you decide how many golds or how many silvers? Because there's going to be a trade-off of quality and the cost of dispatching.
Okay. All right. Of course, there was slight hand waving going on. Just very slightly. Clearly, everything I said focused on the supply side, and in a sense, the demand side was simply, the demand side had simply revealed that it wants 10 gold and 10 silver. Okay, of course, the ultimate goal would have some two-sided auction where the demand side's revealing it as well. But of course, the demand side can be coming into this because of demand response on gold and silver. Okay, so I'm able to offer some gold response and some silver response. Okay, so the answer is, that the demand side is what's determining. Is it gold or is it silver? And and clearly by setting up gold and silver, you're saying, well, hang on, if you're prepared to just take silver, you can have it cheaper. Okay, so so there are prices that demand side is now responding to here.
How much complexity does that add, making it more symmetric between the?
I think the answer is it's not clear that it does add much more complexity, because I think you can just have it as negative load. Okay.
Questions? All right. Thank you.
Thank you.